Okay, let's look at example 4. In each case, we're going to be solving for x. And in each case, rewriting that value using exponents is going to be the most important step. Let's go ahead and do that in example 1. 1 million. 1 million is the same as 10 to the 6th. What that means is we can rewrite this as 10 to the 3x, that's for this piece, equals 10 to the 6th. Now we can use what's called the power of equality. If 10 to the 3x equals 10 to the 6th, if we know the whole equation is equal, and we know that these two bases are equal, that automatically means the exponents have to be equal as well. So we're going to take our exponents, 3x and 6, and set them equal to each other. Right? So if the equation is equal, or if both sides are equal and the bases are equal, it has to be true that the exponents are equal. So we're going to make those exponents equal and solve. And we get x equals 2. 3 times 2 equals 6. Smiley face. B, we're going to use the same idea. The only difference is we don't know the exponent required. Here we know that 6, because 1 million is a very familiar number to us. We know 1 million is 10 to the 6th because we can count the zeros. The first thing we need to do to solve this one is figure out what in the world log 33,500 is. And I have no idea. So I'm going to press my log button, 33,500. And what we get is it's 4.525. And we'll stop there. 3 decimal places is always a good point of accuracy. What that means is we can take this side of the equation, this side of the equation, and rewrite this problem as 10 to the 9 minus x equals 10 to the 4.525. Right? That's what the log feature does. It tells us the exponent we need to rewrite that number. So just so it's clear, this piece right here, that's this piece. And we have our equals, and then this piece is now that piece. Okay, or that term, I should say. Now we're going to use the power of equality. If the total is equal and the bases are equal, then we know the exponents have to be equal to. And we only know that's true if the bases are equal. That's why this is such an important first step. This step allows us to take each exponent and build a new equation. So 4.525 equals 9 minus x. And then here we're just going to solve. So there's a few ways to solve this. Let's add x to the right side to get rid of that minus x. So now we have 9 equals 4.525 plus x. And then now we want to get x by itself, so we need to subtract 4.525. Subtract 4.525. Run out of room. What we get is 4.474 equals x. Got a little bit messy in there, but the most important thing is this side is written using 10, so that's fine. We need to take this side and rewrite it using 10. So that's what we use that log feature for. That gives us our new right side, and then we just take our exponents and make them equal and solve for x. And at that point, we're just solving equations. C, we still have that same idea. We want common bases. We want a 10 and a 10 so that we can set up an equation. The only difference is we actually want to move this 5 first. On the homework, I think it's not a 5, it's a different value, but we need to divide by 5. And then over here, we need to divide by 5. And so what we wind up with is 10x plus 2 equals 1,000. And now we're back into something very similar to A. We're going to leave this side the same. This is the same as 10 cubed. So we have 10x plus 2 equals 10 cubed. And then since the bases are equal, that means the exponents must be equal. So x plus 2 must be equal to 3. Right? This and this, they must be equal. And if x plus 2 is 3, x is 1. Check mark, flag, DSA. All right. I think there's only one more. It's just a factoring review problem. That solution is going to happen pretty quick in example 5. Go ahead and click over. Keep up the good work.